All right, so this is single number 4 with the 6 different types of chemical reactions. And I have to teach someone outside of the classroom. So here I have my mother with me.
Hello.
And so I'm going to teach her the 6 different types and how to balance them. So the first one that we have is the single displacement reaction. And the meaning behind it is that, so in every single reaction, there's a reactant and a product side. The reactants is what you put in so that the reaction can happen, and the product is what comes out of the reaction. So single displacement is when there's a compound in the reactant side, and when it reacts, what happens is we have hydrogen and chlorine here. We're gonna call them, A and B. So hydrogen is A. He's gonna break up with the chlorine and just be by himself. And the ZN right here is gonna merge with the chlorine. So that's what it means. Just one of the elements breaks up, and we're gonna need to balance it because right now it's unbalanced. So what we're gonna do is we're gonna list each different type of element, and so we have Zn, H, and Cl. So this side is going to be the reactant side, and this side is going to be the product side. So we're going to list how many of each we have. So with Zn, we have 1, H, we have 1, and Cl, we have 1. So on the product side, we have 1 Zn, 2 chlorines, and 2 hydrogens. Now, you can see that it's not balanced.
It has to be the same, right?
Yes, it has to be the same. So what we have to do is we have to balance them. So you always go from top to bottom. See, right now the Zn is balanced, so we're not going to mess with that. So now we're going to go with the hydrogen and the chlorine since they're unbalanced. So what we're going to do is we're going to put a 2 in front of the hydrogen and chlorine, and that's going to change the hydrogen to 2 and the chlorine to 2. So look, now we have a balanced single displacement reaction.
Cool.
So now the next one is a double replacement reaction where 2 elements from both compounds switch and replace each other. See right here we have NaCl plus AgNO3, and the product of that is NaNO3 and AgCl. And see how the Ag and the Na switched and combined with the other. So we're gonna try and see if this is balanced here. So we're gonna list all of them. Na, Cl, Ag, N, and O. Now we're gonna split the N and O because even though they're a compound, you still need to separate them.
Because they're 2 different elements?
Yeah, because they're 2 different elements. Okay. So with the Na and Cl, we each have 1. With the Ag, we have 1. With the nitrogen, we have 1. And oxygen, we have 3. And so on the product side, we have 1 Na, 1 N, 3 O's, 1 Cl, and 1 Ag. So you can see the reaction.
Balanced.
Yeah, the reaction is balanced already, so we don't have to mess with that. So with the now we have an acid
And that
base.
was what, the double?
That was the double replacement. So now we have the acid base reaction. So with the acid base reaction, you're gonna have an acid and a base. So the acid here is hydrogen, and the base is bromine. All right, and
I didn't know H was acid. Okay.
And they're gonna combine with oxygen and hydrogen because you usually have those in an acid-base reaction, and they're most of the time when you have the O and the H, it's gonna form H2O. So now we're gonna see if it's balanced yet again because every reaction has to be balanced or else stuff goes down.
Okay.
So we have HBr and A, and just like we did with the NO, we're going to split up O
The O
and
and the
H.
Okay.
I mean, we don't have to list H again because it was already there. So now here we have uh, two H's here, since we have the hydrogen that's with the bromine, the hydrogen with the O, and the
yeah.
Na.
Okay.
So we have two. And now we have a single bromine, a single Na, and a single oxygen. Now, on the product side, we have one Na, one Br, two hydrogens, and also, look at that, one
Nice.
oxygen. So it's already balanced for us, and we don't have to do anything. So now, this is a combustion reaction. So what a combustion reaction is it's when carbon and hydrogen react with oxygen to create carbon dioxide and most of the time water. So here we have C10 plus H8 plus O2, and the product is CO2 plus H2O, which is carbon dioxide and water. So now, see if it's balanced. You have C10, H8, and O2. Now, on the product side, we have one C, two O's, and
Two.
oh no, sorry, we don't have two O's. We have three O's because we have
Yeah.
the two O's here and the O in water. So we have three here and two hydrogens. Now, automatically you see, oh my God,
Super unbalanced.
super unbalanced, yes. So what we're going to do is we're going to put a big fat 10 right in front of this carbon dioxide to make that 10. So what's that going to do?
Wait. Oh, to make that 10.
To make it even, because you got to go from top to bottom. So that's going to make the carbon even, but it's also going to change the oxygen, which is going to be a whopping 21,
What? Why?
because you did 10 times 2, which is 20.
Oh, it's times.
Yes,
Okay.
you have to multiply it. Yes.
Oh,
And then, yes. So now since we see that that's even, we got to make the hydrogen even. So with the hydrogen, we're going to go with, since you see that it's 8 and 2 here, we're obviously going to go in front of the water and put a 4 there so we can multiply to 8. And you see that that's balancing. Now that we put a 4 in front of the O, it's going to be 24 now. 24. You see that? Yeah. 10
What?
times
Oh, okay.
10 times 20 is 10 times 2 is 20. Plus if you when you put a coefficient in it, it affects everything in the compound. So it's going to
even
affect,
from the beginning there?
yes, it's going to affect this
It's
carbon
going to affect
dioxide.
everything that comes after.
Yeah, but just the carbon dioxide, not the water.
Oh, okay. But the 4 that you put in front of the
The-
H affects the water.
Yeah. Affects the whole thing.
Okay.
So it's going to be 24. So what we're going to do here is,
I don't
since
get
that's
where you got the
24,
24 from, but okay.
10 times 2 is 20. 4 times 1 is 4. 20 plus 4 is 24. You see what I did there? Just imagine that there's a 1 there.
Oxygen here and there. Got
Yes,
it. Okay.
just
got it.
imagine that
Got it,
there's
got
a
it.
1 there.
Yeah.
All right, so we're going to put, so now that we see that oxygen is way uneven, we're going to put a fat 12 in front of the oxygen on the reactant side. And we see that 12 times 2 is
makes it
24.
All right.
Okay, so that's our combustion
I
reaction.
don't remember doing all this stuff in high school, but that was a while back.
So now we have our synthesis reaction. Our synthesis reaction is when, so the normal, let's say, algebraic equation would be A plus B reacts to form AB. So they're going to each combine. So both elements are going to combine to create one product. So you see here we have the NO plus O2, and that's going to create NO2. So Now we got to see if it's balanced. So we have N and O. So now on the reactant side, we have 3 since we have O and then O2. So there's 3 there. And then we have 1 N. Now on the product side, we have 2 oxygens and 1 nitrogen. So you can see the nitrogen is
Balance.
Balance,
But the oxygen isn't.
yeah. So excuse me. So what do you
How are you gonna make that 3?
so what do you see here? We see 3 and 2. Now, what I'm gonna do, you're gonna say 6, right? Not necessarily. You don't have to do it by 6. What you can do is you can put a 2 in front of the NO, so that's going to make the oxygen 4. But that's also going to change the N to a 2, so because it affects everything. So now both of them are unbalanced. But wait, there's more. So we're just gonna move this so we can make some room. And then right here you see 2 and 4 NO2. Oh, easy. Just gotta put a 2 there, and that makes N2 and O4. And now we have a balanced
Balance.
synthesis.
Sorry, I'm moving a little bit. Trying not to make your teacher dizzy here.
And now we have a decomposition reaction. Now this is the complete opposite of a synthesis reaction. We had 2 compounds that combined to create one product. 2 reactants that combine to make one product. Now we're going to have one reactant that's going to make multiple products. So it's going to break up.
You still have to balance that?
Yes, you have to balance everything. So now we have H and O. So on the reactant side, we have 2 and 2 for both. And on the product side, we have 2 for hydrogen and 3 for oxygen. So this one looks just like the one we just did with the 2 and the 3. Okay, so what we're going to do is we're going to put
Don't move this so.
So we're going to put a 2 in front of the H2O, and that's going to change the H to a 4 and the O to a 4 because you have to imagine that there's a 1 there, so 2 times 1 is 2 plus the O2 would be O4. And now
What do you mean?
you have to
'cause
always
have
imagine
this-
that there's a
You have the other one.
1
then.
here.
No, I forgot you.
Yeah, we have the
That there.
O2, yes. And now we have to change the reactant side since they're both uneven now. So now we're going to put a 2 there, and now they're going to both change to 4 and 4. And there you go. You have a decomposition balanced reaction. So these were all 6 of the chemical reactions, and as you can see, we balanced all of them. And we explained all of them. So, all right.
It was very interesting. Thank you.